All right, let's look at some examples here on how to determine the shape of the molecule and identify the bond angle. So the first thing that we have to do is we have to draw the Lewis electron dot diagram. So for NH3, again, this is something that we've already covered, so I'm just going to do this part rather quickly. NH3 looks like this. Okay, and then it says identify the geometric shape of the molecule. So here is, again, it doesn't matter how I drew it. All that I do now is I go, okay, NH3 has 3 bonds and 1 lone pair. And then it's my job to remember that any molecule that has 3 bonds and 1 lone pair is a trigonal pyramidal shape. Okay, and that is identifying the geometric shape of the molecule. It doesn't ask for it, but we could also say that the bond angle would be a little bit less than 109.5. If I ask you on a test, what's the bond angle in NH3? If you said 109.5, I would give you credit for that. Okay, okay, so O3 is going to look like this, and again, I've done this enough where I can kind of just do these in my head now. Okay, O3 looks like this. So again, we've got 2 bonds. Remember, a double bond just counts as 1 bond. So 2 bonds, 1, 2, and 1 lone pair on that central atom right here. And that creates a bent molecule. Okay, what? No, it's not. It's linear. Just because I drew it linear, remember that doesn't mean it's linear. Okay, and then again, it doesn't ask for the bond angles, but again, the bond angle is going to be roughly around 120, a little bit less than 120 degrees. Okay, SF2 is going to look like this. Has 20 electrons all total. Okay, and then again, I count the bonds, 2 bonds and 2 lone pairs. So 2 bonds and 2 lone pairs is also a bent molecule, but in this bent molecule, the bond angles are a little bit less than 109.5 degrees. So that one's a little bit more bent than the previous bent one. And then PF4 plus is going to look like this. Each of the fluorines with 6 dots on them. Looking just like that. So there are 4 bonds and 0 lone pairs on that central atom. That is a tetrahedral shape. And again, bond angles there are 109.5. Okay, in example 2, it says list the following molecules in order from the smallest bond angle to the largest bond angle. Well, really, to do this, you have to draw the Lewis electron dot diagram. You have to draw you have to know the shape, and then you can look at the bond angles. So for H3P, again, I'm just going to do these quickly. H3P looks like this. So that, again, is similar to actually NH3 up here. It has 3 bonds and 1 lone pair. So that is a trigonal pyramidal shape. Again, they don't ask for it, but the more you hear it, the better you're going to understand this. Okay, and those have bond angles that are slightly less than 109.5. On SiCl4, each chlorine is going to have 6 dots. Again, I'm trying to move quickly, but that is a tetrahedral with 109.5 degree angles. So which one's smaller? pH3 is smaller because, again, pH3, it was a tetrahedral, but we took one of those bonds away. So it has 3 bonds and 1 lone pair. And so that's slightly less than 109.5. Okay, SO2 is going to look like this. It looks like the ozone one, the O3 one up there. Okay, 2 bonds, 1 lone pair. So that is slightly less than 120 degrees because, again, 2 bonds, and then the 1 lone pair is 3 all total. So with 3, that's a 120, but you take that away to give you that bent molecule. Okay, and then BF3 looks like this. Again, boron does not get 8 electrons. Okay, 3 bonds, no lone pairs, so that is just a straight 120, not less than 120. So which one's the smallest? H3P. okay, because it's slightly less than 109.5. And then we've got SiCl4 would be next, not Y, SiCl4. And then our next one would be slightly less than 120, so SO2 would go next, and then BF3 would have the largest bond angles. So here we have our smallest bond angles, here we have our biggest bond angles. So you need to be able to, just like I did here, you need to be able to draw the Lewis electron dot diagram and then look at the Lewis electron dot diagram and determine how many bonds there are and how many lone pairs there are. And then you need to remember, yes, this is something that you need to remember, okay, the 6 different shapes that we've learned. Oh, but Mr. Johnson, that's so many shapes we have to learn. Okay, I'll be honest with you, there's actually 13 shapes. Okay, notice that we stopped at 4. There's actually shapes that are based around 5 bonds and molecules based around 6 bonds. But because this is just general chemistry, we're stopping here with the ones that only have 4 bonds. But there are a lot more molecules that you can know up to 13 shapes. So be grateful that you only have to know 6 of them. Okay? So you need to be able to know those shapes based on the number of bonds and lone pairs. And then you also need to be able to predict, like we did down here on example 2, you need to be able to predict the different bond angles.